Any radical with an even root is going to be a little bit different. Right, and so when we look at this example or this set of examples here, what we see is we still have equations of or functions of a quadratic type. Okay, here's 1 power, 1/2 is exactly double the other, because 1/4 times 2 is 2/4 or 1/2. So this still is an equation of quadratic type, but radicals aren't always expressed in terms of the square roots or the fourth roots. They might be expressed in terms of rational powers. So you have to be aware of that rational powers are radicals. Okay, and so when you solve a problem like this, we can still follow the same process. We let u equal our lesser power, so p to the 1/4, meaning u squared is going to be p to the 1/4 squared, which gives you 2/4 or 1/2. And that allows you to rewrite this as a u squared minus 7u plus 12 equals 0. Okay, and so if you solve this equation here, the two factors of positive 12 whose sum is -4, or -7 is -4 and -3. So we would have two values for u. U is 4 and u is 3. Okay, once you get to that point, you back substitute. U was p to the 1/4. So if we plug that in and solve each of these, here we take and undo the rational power. We take both sides to the power of 4, giving us p is equal to, now 4 to the 4th is not necessarily a common number, but if you multiplied it out, you get 256. Take both sides to the 4th here, leaving us p is equal to 3 to the 4th is like saying 3 squared squared. 3 squared is 9, 9 squared is 81. That one can be done mentally. Okay, and so you have these two possible numbers to choose from. Because we were dealing with rational powers, which are radicals, we do need to test and make sure these work in our original form. So if I took the square root, p to the 1/2 is the square root of 256. I get 16 minus 7 times the 4th root of 256, which we see right here is 4, plus 12. Does that equal 0? And you can see 16 plus 12 is 28, minus 28 does equal 0. So 256 checks. Do the same with 81. The square root of 81 is 9, minus 7 times the 4th root of 81 is 3, plus 12. Is it true that 9 plus 12 or 21 minus 21 does equal 0? Once again, yes, that checks. Okay, and so we have these two possible solutions here. Look at this example right here. We're going to talk next week or next class about how to solve radical equations. And this is a problem that because the q to the 1/2 is the square root of q, you can solve this using the methods we'll talk about later. But if you can recognize right now that this does fit the quadratic type, we have 1 power of 1/2 and 1 power of 1. Is 1 exactly double 1/2? Yeah, so what we could do is we could let u equal our lesser power, q to the 1/2. And if that's the case, then u squared is going to be equal to q to the 1/2 squared, or q to the 1st. Meaning we could rewrite this as u squared minus 2u minus 8 equals 0. And then we can solve it as a quadratic equation. If that were the case, we can look to factor. The two factors of -8, whose sum is -2, is a -4 and a +2. So we get two possible values for our u, a +4 and a -2. Okay, once we get to that point, we can back substitute. So here's what u is equivalent to. The square root of q, or q to the 1/2. Oops, and this is a negative. Okay, and so when we look to simplify this, can you take the square root of a number and get a +4? Yeah, so we're going to square both sides to find that number, and q is equal to 16. Okay, can you take the square root of a number and get a -2? No. So this is going to be extraneous. You don't even need to work through and solve it. You see that already. So our answer is 16. We do want to test it. Anytime you're dealing with radicals, you want to test your answers. So here we look at 16 minus 2 times the square root of 16, which is 4, minus an 8. Does that equal 0? 16 minus 8 minus 8, yes. Okay, and so the only solution that you have here would be 16. Okay, talk through this final one here really quickly. I'll write the answer to the middle one, and then I'll let you know what you have for the rest of this class here. Okay, so if we jump down to this last problem here, again, when you're looking, you have y to the 1/2 and y to the first. This is of quadratic type. One power is exactly double the other. So we can use u substitution and let u equal the lesser power, y to the 1/2, which means u squared is going to be y's. And if we substitute those in, we get our equation written in terms of u's, which is a quadratic equation. We can then factor the factors of positive 60, whose sum is negative 17, negative 12, and negative 5, giving us 12 and 5 for our u values. And so when you back substitute, plug in the u or the y to the 1/2 for each of these u's, which is the square root of y. We can undo these by squaring both sides, and we get y is equal to 144 and y is equal to 25. Okay, you do want to double check these anytime you're working with radicals. So if I test, I have 144 minus 17 times the square root of 144 plus 60. And again, if you test those, you do see that they cancel each other out. 144 is correct. Do the same thing with the 25. 25 minus 17 times the square root of 25, or 5, plus 60. Once again, when you simplify what you have, those do cancel out, giving you 0. And so both of these would be your remaining solutions.